Alright, hello again. This is Jeff Scott from Blackhawk Technical College. We've been going over the textbook starting out with Java 6th edition by Tony Gaddis for the 152-143 Beginning Java Programming class. I have previously gone over the first 11 chapters, the PowerPoint lectures, and for the first 8 chapters of the book I've also gone through a lecture on the book and a lecture where I've gone through an example of a payroll program. Now we're into Chapter 9. Chapter 9 is a relatively short chapter, and I think that for this chapter I'm not going to have any payroll example. I think I'll wait off on that till Chapter 10. So this will be the only lecture other than the PowerPoint one for Chapter 9. So as you can see here, we'll talk about wrapper classes. Then we'll go in and talk about character testing and conversion with a character class. Talk about some of the string methods that are available in Java. And remember, the one thing about strings is strings are mutable. And if that doesn't make any sense to you, because I do want you to understand that, in English, what that's saying is, if I come through here and I'm writing a Java program and I do this, I say string first name equals Jeff. And then someplace, I'm just going to put some dots here, someplace later on in my program I put in first name equals, and I decided I want my proper first name, so I changed it to Jeffrey. Well, when I did this up here, someplace in memory, and let's just say at location 1000, it's going to put in the machine language equivalent, so the zeros and ones that make up JEFF. When I go back down here and I change it from Jeff to Jeffrey, it's going to grab a different location in memory, and I'm making these locations up, and it's going to put the machine language equivalent in there. The reason I'm telling you that, and the reason that this is important, is this original storage location now is basically garbage. It's still holding a value, but the value has no meaning for the program. So what happens is the garbage collector comes around and says, oh, nobody's referencing this, so it marks it as being unreferenced. Well, then when it comes around again, if that same location in memory is still being unreferenced, it removes it from memory. Alright, so that is what is called an immutable string. On the other hand, with a string builder, which is part of what's discussed in this chapter, string builders are what are called mutable. So you can change them, and we'll talk about that in just a bit. Alright, we'll talk about tokenizing strings, and that's grabbing, for example, the way that we speak. In fact, let's take a look right here. Alright, if we looked right here, this is a paragraph, and this paragraph is made up of 2 sentences. These 2 sentences are each made up of words. Those words are each made up of letters. I could tokenize this paragraph, and the way I would tokenize it is I'd say that after every word there's a blank space. So the tokens would be blank spaces. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and I could keep going, so you get the idea. And we'll talk about string tokenization. Then we'll talk about some of the wrapper classes for the numeric data types, and then there's a couple different examples at the end. A test score reader class and a serial number class. Alright, so as mentioned here down toward the bottom part of page 559, Java provides wrapper classes, and guess what? You've looked at them already. We've looked at things like integer.parseInt and double.parseDouble. So we've looked at those already. There are other ones too that we'll talk about in just a couple minutes. Java has a character class. As it says, it's another wrapper class. Notice it's character with a capital C. Alright, because it's a class. It's a wrapper class, so it's a way of, for lack of better words, wrapping its way around a simple primitive data type to allow it to use different types of methods. Okay? So I can check an individual character to see if, for example, if it's any one of these. These aren't all of the things that are in the character class, but it's some of them. As always, as mentioned before, this is not This does not have every example in it. So if I went out, as we have been, to java.sun.com, and we went and looked and found the Java APIs and chose SE8, and if I come down in here, sooner or later, I'm going to find character. And there it is. And there's class characters. So again, you're going to see as we start working our way down here, there's a boatload of stuff in here. So our book is just giving you some of the methods and some of the stuff that you would probably see and probably use the most often. But this is by no means an exclusive list. So I could look at an individual character, and you'll notice that all of these things start with is, which are typically what this means is these are what are known as predicate methods. And a predicate method is typically something that will return true or false. So some of those methods are shown right here in the program that's on pages 561 and 562. Okay? Yeah, that's fine. I'm not going to go over it any more than that. Same kind of thing with a customer number. So if you wanted to make sure that the person put their customer number in a certain format, in other words, 3 letters followed by 4 numbers. All right, and if you didn't, so this would be valid, for example. All right, then you've got a valid method, and what that valid method or is valid checks is, it says, okay, if it's not equal to 7, remember 3 letters and 4 characters, if it's not equal to 7, it's no sense in going on. You're done. But if it's 7 characters, okay, then let's look at the first 3. If each one of those is a letter, all right, you're okay. But if you find one that's not a letter, you set that equal to false, and again, you're done. So when you get down to here, if you get down to this point right here in line 54, whatever you inputted was 7 characters. If you get down to the next check that you have down here, so if you get down on line 62, you know that A, what you put in was 7 characters, and B, the first 3 characters were letters. So you do a similar check, but for numbers, where is digit. So you can see that's valid, and then they've got another one in here that's invalid. And he explains this in much depth and breadth of coverage, probably better than I just did. There are character conversion methods to take characters and convert them to uppercase or lowercase. Now that is only going to work if they're alphabetic letters. And as they say right here, if you try it on something like special characters or numbers, they have no uppercase equivalent. This is most often how this is going to be used. All right. If you tell the user to enter a Y or an N if they want to continue, and you want to make sure that the Y that you check is an uppercase Y, then you run the to uppercase method on it. That's all. All right, more string methods. Well, much of the work that gets done with strings is searching for substrings, which is a string inside of a string. And you can see there are examples here, starts with and ends with. So does the string 4 score and 7 years ago, does it start with 4? It does, so it's going to return the string starts with 4. If we had put in here 5, for example, it would have said the string does not start with 5. So on page 569 here, they have many of the methods that you would use to search for a substring. And again, it's not my goal here to go over all these. I did talk about these in some depth when I went over the PowerPoints. So they've got a person search in here. And notice they've got a bunch of different names. Will Cutsaw, George Davis, Phil Russer, Jenny Davis, etc. So for instance, if I put down DAV. Okay, it should find Jenny Davis, and it should find, but there was a George Davis as an example. And that's the example they show. Notice you can also put down part of a word, Russert and Russell. Okay, and if we had come in here and let's see, let's say that we had put in W-I-L-L, we would have found a first name of Will and a last name of Williams. All right, so you can use this in a variety of different ways. Part of the reason that this stuff is so important is you work a lot, and I mean a lot, with string methods when you're working with databases. All right, here's some more methods. Index of. For searching for a certain character and where it's found. You can search in both directions too, just so you know. And it'll give you the first instance if one is found, the last instance if one is found. And they've got, again, examples of those in here. More work with substrings. There actually is a substring method. And I think there's a pretty good example in here. Remember, this always starts with 0. So this says full last name equals full name dot substring 14. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Which is going to put us right, come on, right there. So the last name is going to be Lee. All right, not the greatest of examples, but hopefully you can see what's going on once you start doing that. Notice on the bottom of page 576, there's a get chars and a to-char array, which converts strings into character arrays. And why would you want to convert strings into character arrays, or for that matter, character arrays into strings? Because sometimes, for example, here in the example they give, maybe there are some methods that you can use on arrays that you can't use in strings, or vice versa. So you convert one to the other to be able to do whatever it is you want to do with them. And again, notice they put in here 99 red balloons. And it says that that is 11 characters, 2 of which are white space, 2 of which are digits, and 9 of which are letters. And we're not showing here whether they're uppercase or lowercase, although that could be done too. Strings that modify, or methods that modify a string. Concat, which allows you to combine 2 or more strings together. Replace, which is like the replace that you use, for example, in Word. And trim, to remove leading and trailing characters from a string. Some more value of. This can be really important because notice, especially the last 4 that are in here. Let's look at this one. String value of int number. This value returns the string representation of the int passed into it. So you pass in a number and it converts it into a string. We talked about how to convert a string into a number with using like the integer.parseInt. This is the reverse, the value of. So I talked a little bit before about the string builder, and as I mentioned, the string builder allows you to do things that you cannot do with a string. As they mentioned on the bottom here of page 582, the main difference between the two is that you can, C-A-N, change the contents of a string builder object, but you cannot, all right, change the contents of a string object. Strings are mutable, whereas strings are immutable, whereas strings are mutable. And this is very similar to the example I showed you before. If you change on the address here from George to Sally, for example, something like that, then this is no longer referenced, so sooner or later the garbage collector will remove it. Let's talk about for a second why you might even want to use something like this. Why would it even matter? Well, I could have a string where I asked a person to put in their first name. I could have another string where I asked them to put in their last name. But you know what? Maybe as they put it in, maybe they'd want to change it. So maybe I'd put it in first as first name Jeff and last name Scott, but later I'd want to change it to Jeffrey. So what I could do is, instead of having those be string objects, I could have them be string builder objects. And after I had the first name and I had maybe the middle name or middle initial and the last name, I could combine them all together. Then when I got done, I could convert that string builder object into a string object. And you see a lot of that kind of stuff done. So the string builder by itself, if you set it up with nothing in here, by default it'll hold up to 16 characters, even though there aren't any in there yet. You can also put a number in here, so if I put in 100, it would hold up to 100 characters. Alright, and in both these two cases, this one and this one, the string is empty, but here I can also give it an initial value. And it says the initial value will be the length of the string plus 16. Different things that you can do with string builders. I'm not going to read any of these to you, but again, the idea is that you're able to, while the program is running, so at runtime, you're able to change the value that's inside of a string builder object. You'll notice that in table 9.9 here on the bottom of page 584, that many of the methods that are available to strings are also available to string builder. But string builders have an append, for example, that strings don't have. They have an insert that strings don't have. They have a remove, or replace, I should say, that strings don't have. A delete char at, and a set char at, where you are, again, the idea is that you're able to, while the program is running, change the value of what's in your string builder variable. And that's the magic of this, so to speak. If you need to convert a string builder into a string, you can use the toString method. Okay? They've got a kind of an interesting program here that starts on the bottom of page 587, and it says that phone numbers typically are in this kind of a format. All right, so they allow you to put it in like this, and they'll change it for you. And he goes through a fairly long explanation of how this can be done. Again, he's got a lot of good examples in here. There's just not really enough time to go over everything that's in here. Alright, tokenizing I mentioned before. Here's an example that inside of these double quotes you've got 4 strings, and the value that you're using to tokenize them is a blank space. Sometimes you'll have that, sometimes it'll be a different value. For instance, here's a list of numbers, 1, 2, 3, 4, 5, 6 numbers, and the token between them is a semicolon. Sometimes you'll be working with a calendar date, and the token between them is either a hyphen like this, or maybe a /. So there's a lot of ways that you can do this. And what you can do is by tokenizing, as it says, the string class has a split method. So here we've got this, and we're telling it to split, but we're telling it to split based off of when you find a blank space. So it converts that string into these 4 separate tokens. PHP has something similar to this that's called implode and explode that we'll look at a later time in another class. Sometimes you've got more than one different delimiter. For instance, in here, this is a delimiter, the @ sign, and this is a delimiter, the period. So if that's the case, you have to be able to put in the fact that, oh, I've got several different delimiters in there. So as it says, if you put in that you've got an at and a period, it turns that one line into these 3 tokens. You can run the trim method. Remember, trim gets rid of any leading or trailing spaces, so that would change that. It would get rid of that space and that space. Probably a cleaner way to do it. Wrapper classes for numeric data types here on page 597. As the author mentions, the Java API provides wrapper classes for each of the numeric data types. Remember, numeric, so there isn't one for Boolean, there isn't one for char, but the other 6, byte, int, short, long, double, and float. They look just like their primitive types, except there's a capital letter instead of a lowercase letter. As it says, each of these numeric wrapper classes has a static toString method to convert the number to a string if you have to do that. There's also binary, which is base 2, hex, which is base 16, and octal, which is base 8 methods. All right. The min value and max value constants, as mentioned here by the author, the numeric wrapper classes each have a set of static final variables named min value and max value that holds the minimum and maximum for a particular data type. All right, and they're constants which have the max and the minimum value for the system. Probably the hardest part of this chapter right now is the next few pages. They talk about autoboxing and unboxing. And they mention it's possible to create objects from wrapper classes. It says one way is to pass an initial value. So what we have here is integer number, notice that's a big I, equals new integer 7. And as mentioned here on the next page, this creates an integer object that has a value of 7. And it's referenced by the variable number. So they say, well, maybe it's easier to look at if you break it down into 2 statements. The first statement declares an integer variable, but remember this is an integer object variable named number. It doesn't create the actual object, it just creates the variable. The second statement is an assignment statement. It assigns a primitive to the variable. And the reason that works is number is a wrapper class, and Java performs what's called auto boxing on it. And they mention this in this first big paragraph here on 599, that auto boxing is the way that Java automatically boxes up a value inside of an object. So when the statement executes, Java boxes up, or it puts a 7 in that integer object, and then it assigns that address to the object, of that object to the number variable. The opposite of that is unboxing. And there are some really good articles out there online that explain this much better than the book just did, and I'm sure much better than I just did. All right. The last stuff that's in this chapter is they've got this thing where there's this professor has got scores for different students or whatever in an Excel spreadsheet, and writes a test reader class to convert those from the spreadsheet into actual file values, so he can grab them out of there and do this with them. Okay? That pretty much is it. What I am going to do, if I have time, I might be done, to be honest with you. I've gone over the PowerPoints for chapter 10 and 11. I have never gotten this far to chapter 10 or 11 with a class before. So what I think I'm going to do is just stop it here at chapter 9. That will be the actual last lecture that I will be giving right now. And then in class, we're going to go over these payroll programs as a class. Okay, so that's pretty much it for right now.